Hi everyone, so today we're talking about the introductory ideas in an atomic structure. So there's three different parts of an atom, which are the particles. So we have protons, which are positively charged, electrons, which are negatively charged, and neutrons, which are neutral. Okay, so the first one we're going to have a look at is sodium. So as you can see in the box I've drawn on the left, the element is Na. The number above is the atomic number. That's also the number of protons and the number of electrons. The number below is the mass number. As you can see, it's 22.99, but I've rounded it up below. To calculate the number of neutrons, we just need to take the atomic number away from the mass number. So 23 minus 11 is 12 neutrons. So it's 12 neutrons, 11 electrons, and 11 protons. Where we're looking at shells, for example, so a shell, in the shells, in the first one you can fit 2 electrons, second one you can fit 8, third one you can fit 18, and in the fourth you can fit 32 electrons, and so on. With this, just because we only need to fit 11, so the first shell's got 2, second's got 8, and the third one's got 1. However, when we look as a sodium ion, so an ion is one that gains or lost electrons, it becomes positively charged because we've lost one. So as you can see, it's just 2, 8 is the electronic configuration. And then next to it, we've got the orbitals. So we have the s subshell, so it's 1 s orbital, p subshells have 3 p orbitals, and d subshells have 5 d orbitals. In this one, what we do is we have 1 s2, 2 s2, 2 p6, and 3 s1. When it's an ion now, as you can see, we've lost a 3 s1 because we've lost that electron. Also, as you can see, the sodium atom has 1 electron in the last shell, and this relates to the periodic table, so I'll just show you that. And this relates to the periodic table because, as you can see here, Na comes under 1 on the groups. So these numbers at the top, so 5 for example, that means it would have 5 electrons in that last shell. Also on this first picture, 1s, 2s, 2p, that's just electronic configuration. So when you're filling these subshells, when you are filling them up, the 4s comes before, as you can see, comes before the 3D. This is because 4s has a lower energy level, so you need to fill that up first. Okay, we'll just skip that one, I don't think I'll have time. The next one we have a look at is zinc. So zinc, for example, is 30 as the atomic number, 65.38 is the mass number, so that means there's 35.38 neutrons, just round up to 35. And we have 30 electrons and 30 protons. As you can see, when we're looking at the shells, we have 2 in the first one, 8 in the second, 18 in the third, and 2 in the fourth. When it becomes an ion, though, we have lost 2 electrons. So it's just 2, 8, and 18. So as you can see, we've lost that fourth shell. And also, just so the idea I mentioned before with the periodic table, you can see there's 2 on that last one. And then, oh, sorry, it won't let me go back. Okay, the electronic configuration on here, 1s2, 2s2, 2p6, and so on. As you can see, the last one is 4s2. When it becomes an ion, we have lost a 4s2 because we lose them 2 electrons. Okay, and here when we're having a look at the electronic configuration to work it out, we have the energy on the side, and each box represents 1 orbital. As you can see, they're all going up, and also as you can see here, we've got that 4s before the 3D because of the lower energy level. And also, as you can see, the arrows, so each arrow represents 1 electron, so they spin in opposite directions, as you can see here, which is called spin pairing. And electrons fill orbitals singly before they start pairing up. As you can see, I've done it here, and when we look at the zinc ion, the last 2 we have done it there also, so we filled them up before putting them as pairs. Okay, so the last one we have is sulfur. As you can see, we have 16 as the atomic number and 32 as the mass number. To work out the neutrons, we've just got 32 minus 16, which is 16 neutrons, 16 electrons, and 16 protons. When we look at the electronic configuration, it will fill up as a 2, 8, and 6. So 2 in the first shell, 8 in the second, and 6 in the third. Because When it becomes an ion there, we have gained 2 electrons. So when we gain electrons, it becomes negatively charged. So it's 2A8, and because we've gained 2, it's 2 minus. And then on the last picture, we've got at the end 3p4 and 3p6. Also, because it's gained them, that's why it becomes a 3p6, because it's gained them 2 electrons. Okay, that's all. Thanks for listening. Hope you've enjoyed.